we're going to actually be giving you a little walkthrough over what everyone here does. We are focused on solutions here, not just problems. And we have, I hope, 4 solutions represented by 5 able panelists to my right. So firstly, and kicking us off, if the tech works, is Kirk Bansak.
Hi everyone, my name is Kirk Bansak. I'm a data scientist at the Immigration Policy Lab. It's a social science research lab with branches at Stanford University in the US and ETH Zurich in Switzerland. And one of our primary areas of research is in policy design and innovation, trying to find ways to help refugees and asylum seekers more easily integrate into their host countries' economies and societies. And the project I'm presenting today, that I'd like to highlight today, began with a really simple observation, and that is that refugees' initial geographic placement has one of the most critical and immediate impacts on their ability to integrate and achieve, for instance, economic self-sufficiency. And for that reason, in the recent past, researchers and practitioners alike have tried to find new avenues to help revamp national placement procedures. One of the ideas that's been explored recently is in preference-based matching. An issue there, an obstacle so far has been that preferences aren't yet widely collected. And so my research team and I decided to embark on a slightly different exploration using data that is already widely collected in a number of host countries. That's data on refugees, resettled refugees' outcomes, such as their employment outcomes in their host countries. And actually starting to look at data in the United States and Switzerland, we quickly found that refugees' characteristics, things like their language skills and their age and their networks, play a fundamental role in determining what locations within a host country they're likely to thrive in. And so motivated by this, we decided to build a data-driven algorithm for matching refugees to locations that best fit their profiles with an eye towards helping improve their lives a little, improving some of their integration outcomes. And actually, we work really closely with a number of practitioners and partners. And so the seeds of this idea actually came out of a series of workshops we held in collaboration with the 9 resettlement agencies in the United States in 2016. And then in 2017, we began to try to translate these theoretical ideas into a concrete implementation in the form of our algorithm, which was then published earlier this year along with the underlying code and test results in Science. And then we quickly moved into a more operational phase, trying to develop user-friendly interfaces for our partners and plan pilot implementations. And so there's not enough time, I think, today to go into the full technical details of the algorithm, but the general idea is that it combines supervised machine learning and optimal matching. And in doing so, what it first does is it identifies and discovers any synergies that exist between refugee characteristics and locations. That is, it uses the data to try to figure out what profiles make for a better match for different locations. And then the algorithm leverages those synergies to match refugees to the best locations. And importantly, this is done subject to all the constraints that must be taken into account, keeping families together, respecting different capacity limits of different locations, making sure refugees are only sent to those locations that can accommodate any special needs, for instance, medical needs that they might have. And of course, the purpose of all of this is to try to improve their lives, to try to improve some of their integration outcomes. And backtests using data in Switzerland and the United States suggest that improvements of 40 to 70% above baseline outcomes may be possible. The obvious first goal of this is impact, but we have a number of other guiding principles that are core to our work that I'd like to highlight today and that have already been highlighted in a number of panels today, and I'm sure will be spoken about tomorrow as well. So first is scientific rigor, which is not surprising. We're an academic institution. And for this reason, our partners and we are committed to rigorously testing the impact of our algorithm via randomized control trials as part of our pilot implementations. This is actually something that we've already initiated in Switzerland. A second is openness and transparency. This is with respect to our code and what we're doing, not with respect to data. I would put data security under rigor as well. But with respect to openness and transparency, it's for this reason that upon the publication of the algorithm in Science, we also released all of our underlying code under a completely open source license for other practitioners to be able to refer to and use and modify as they see fit for their own work. Next is ethics and fairness. We're acutely aware of how well-intentioned systems like ours can sometimes lead to unintentional results. Let's say, for instance, disparate impacts across different subpopulations. And so for that reason, we're really committed to monitoring not only impact on average, but also monitoring impact across different key subgroups, age groups, gender, educational levels, to make sure any gains we see are distributed in a balanced manner across those groups. There's also a human component to artificial intelligence. We've integrated our algorithm into front-end interfaces for our partners, the case officers at those partners to use, and it's designed such that it provides them with recommendations and preserves their ultimate decision-making authority. We're seeking to supplement rather than replace human expertise, and finally is flexibility. We've also designed the software so that the algorithm can be as easily as possible modified for different national or subnational contexts to take into account the various constraints or procedures or objectives that might differ across different countries. And given my academic background, I have to also provide the obligatory acknowledgement slides. And with that, I look forward to the rest of the conversation. Thank you.
Greetings, everyone. My name is Mike Mitchell. I am the Associate Vice President for Programs for U.S. programs at HIAS. HIAS is the oldest refugee resettlement organization in the world. We started in the 1880s, and we're doing some good work globally and in the U.S. as well. Today, we're going to share something called Annie. Now, I have a friend in Washington. His name is Mike Nabil. Mike was an asylee, and he fled Egypt when he led a campaign against military conscription. In Mike's case, he faced torture. He ended up in the US. He got asylum where he wanted to get asylum. He made the choice about where he wanted to go. Every year, thousands, up until the Trump administration, 80 to 90,000 refugees came to the United States every year. And this past year, about 35,000 have come. But those decisions are based on where there is capacity at local sites around the United States. Those decisions are not made on what is best for the refugee. Now, of course, all the local organizations make decisions on what they think is best, but that's not based on data. So we decided to develop a tool with several partners called Annie, and Annie is actually the first immigrant to arrive at Ellis Island. And the goal was to improve the outcomes for refugees and for software to offer an optimal match. And now I'm going to give you a demonstration of Annie. And if we can if you can see the video, so on the right there, we're going to go ahead and view the results. Everything on the left is where you input data. And you come up with a screen, and the person actually doing the work pulls up those little boxes, and the blue boxes are actually locations. They identify different constraints, nationality, language, etc. And then the green boxes are actual cases, and those define what, and you could put in any right here, but we've started with language, nationality, family size, and we have 5 constraints that are actually inserted here. We run the program, and we can actually tell you, based on data, how many people will be employed. In this case, out of 38 refugees, we know that 25, or the data tells us that 25 refugees will be employed. Now, there's some other great things about this tool. For example, in this part of the video, you can see that if you move a case from one site to another, it will actually, right here, they're called cross-reference cases, and they all have some relation to each other. Now, if you noticed, when the box went over one side, it actually had red because it would not be a good spot for the refugee. But moving it over to this new location is a good choice, but because it's cross-referenced, it has relatives at other sites. We run it again, and the score goes down by 0.02, so it's a good choice, and everyone can go there. So now, we couldn't have done this work without our partners at 4 universities, and now we're going to talk about the more technical aspects of the tool.
Thanks a lot. So my name is Alessandro Martinello. I'm from Lund. So that was ANI visually. How does ANI work in practice? So there's actually two components in ANI. First, there's a mechanism design on an integer optimization part, inspired from operational research, and its goal. And then the second part is a machine learning component. Now, the first component is very crucial because when we want to resettle, say, hundreds of refugees into a dozen localities or 20 localities, there's potentially very, very many combinations, but only a few of them will be feasible in terms not only of capacity constraints, also number of places at the particular locality, but also what we call service constraints. Say language spoken. If there is a refugee that only speaks Farsi, we want to be able to match it to a locality where there is a Farsi-speaking caseworker, and so on. Average case size to ensure, essentially the first part of the algorithm ensures that ANI suggests to the caseworker an allocation that is fair, especially from the point of view of the refugee. And I think we're going to touch upon this in our discussion. The second part is a machine learning algorithm. It's very similar to what Kirk presented before. Essentially, we want to predict counterfaction employment probability of the refugees in order to select out of those feasible allocations, the one where we predict the highest predicted employment for the refugees. So you saw before the boxes being moved around. That essentially a user-driven way to also add additional service constraints to the first part. So very shortly, backtesting. So we backtested this software against the data that we have from HIAS. If HIAS had this software in 2017, we predict essentially, well, naturally 100% reduction in violation of service constraints because the computer does that, and a 22 to 37% increase in the probability of the refugee to find employment. Okay, so that was ANI, right more or less on time. Thank you for letting us presenting. Words to Snorre. Yeah,
and just to jump in, we are now moving from the algorithm section of the panel to the blockchain section of the panel. Blockchains to my right, algorithms to my slightly closer right.
This is my name. I just go by Snow. I'm the CTO of Diwala. Diwala is a startup that's about 1 year old from Norway. And our first initial market is going to go to Uganda. What we do is to create a platform to enabling decentralized skill identity. There's been a lot of talk about identity today, but identity is a vast, vast subject. That's why we're focusing on the part of the identity that's skill. The meaning is that we give people a decentralized skill proof that's globally verifiable. These skills are not just hard skills, they can also be soft skills. This is all driven by growth mapping and incentivization. I made this very simple because this is our core problem today. We go out and we store data everywhere, and especially skills. We go to schools, they know what we've done, they give us a piece of paper back, that's it. We will turn that around, make sure that the user can have the valuable data they need to go around and actually verify what they've done. Then put the data out of the silos into the user. Like, it's not going to say that the data is not going to be in these silos, but they're at least going to create out a verifiable claim to the user about the skill that they once achieved. So the trust in this aspect is that once it's certified or tested, it will always be provable through a decentralized ledger with trusted anchors. It will always be a more efficient process for certification and attestation. Everybody knows that if you're given a piece of paper today, it's very difficult to trust it. It comes down to the reputation of the schools or reputation of the person who actually provide education. And in the end, this can all give a more trustworthy network of skill because the people are walking around with actual digital proof of verification. The grounds for making this possible is something that is called DID. It's a decentralized identity standard that's that's being created by W3C. We have decided to go with this standard because it's the one that's come the furthest, both in terms of working frameworks and models to follow, and also services like Uport, Sovereign, Yolocom, who provides the base layer for identity and verification, while we can build our skill identity on top of that. This enables such as identificator on a decentralized ledger, meaning that everybody can look this up, not having to go to some sort of database to check what's the identificator of this person. You can stack up a lot of certifications, attestations, verifications of a skill, And these are all verifiable without a central source because of cryptographic signatures and identification registries on a decentralized ledger. What we're trying to do is then to build a service for these already trusted parties like schools or course providers to create their own decentralized identity, mapping out this trust tree. And that's the challenge. How do you build that right trust tree? And that's what we're working on, and we are part of the Decentralized Identity Foundation and discuss this a lot with them to see where does this trust tree begin? Because as mentioned earlier today, the trust is in the real world as to today. Like it's in technical solutions as certifications online, like HTTPS. It's in domains. It's in the government. There's a lot of places that there's trust. But where do we actually start anchoring this onto a decentralized ledger to be able to build the right world we want to live in? So what does this actually mean for the future in terms of what if you then start getting your skills verified without a database and having it ownership of it yourself? You can start getting trustworthiness across borders, meaning that because the data is not stuck with one government, it's not stuck with one school, it's much more easier to trust the registries that's there. It's also trustworthiness across time, meaning that if a school or some course provider actually dies out because of either a catastrophe or something else, they've still verified it at some point. And this is digital and much, much easier to prove in 10 years later than a piece of paper that might get destroyed. It can be globally verified. This is, of course, a very heavy discussion subject. It's what is a skill, how is it verified, but that someone has to begin somewhere, and we have to start this process to be able to achieve it. It's also better, just going digital is easier to eliminate fraud. Having cryptographic signatures is easier to eliminate fraud. And then tightly coupling this up to a decentralized ledger that enables economical possibilities like Ethereum or something can have a lot of good side effects that can enable incentivization and a lot of cool stuff. But right now we are doing pilots in Uganda with educational providers that to verify that this actually has a good value chain for both employers, recruiters, and everybody else that needs to verify some sort of skill from someone.
Hi, everyone. My name's Brianna. I work on RightMesh. My title was just updated at the end of last week, actually. So I'm no longer product manager of blockchain, but I'm actually working on our global partnerships and strategy at this point. So today I'm going to talk to you about the potential of mobile mesh networks and how that can be applied to refugee camp connectivity specifically. So connectivity is obviously core to all of our lives. Many people in this room, I assume, are likely almost always connected. And to refugees, connectivity obviously is of critical importance. These are just a few of the reasons why. Things like navigation, being able to communicate with family and friends, being able to access information about rights and services, and then also simply to share their story. So globally, the digital divide is quite extreme. 56% of the world, and the last I saw was unconnected, which is about 3.9 billion people. So in 2015, the United Nations deemed internet accessibility a basic human right. But unfortunately, the digital divide is much greater for refugees. So why is that so? So there's several different reasons that people are unconnected all over the world, but specifically in the camp situation. The first might be because there's no infrastructure. So that actually applies to a smaller subset of refugee communities. So about 7% don't have any infrastructure. 20% in rural areas have absolutely none as well. But more likely than not, they are actually within range of connectivity. The next is there may be infrastructure, but there just might not be enough capacity to be able to support all the people in that area, which leads to overburdened networks. Next, again, if there is infrastructure, and sometimes if there's not, there could be interference from organizations like governments, which may not necessarily want to provide connectivity to the refugees. One example of that is I was recently in Cox's Bazar at the Kutupalang mega camp in Bangladesh, and there the government doesn't necessarily consider connectivity a right of the refugees. So even though it's technically possible, there's regulatory challenges to actually getting that to them. And then lastly, and most prevalently, expensive data is the #1 reason why a refugee would not be connected. In some studies, it says that up to 30% of disposable income might be spent on being connected. So obviously that's a huge issue, and so I'm first going to take you through the workflow of how a message is sent through the internet today. So if I want to send a message to Alex on WhatsApp, essentially what happens is it goes through a regional ISP to the internet backbone, up to the cloud, to the WhatsApp servers. If we're in China, it might go to the Chinese government, and then back down through that exact same path until it's eventually at the receiver. But we're pretty close right now. Like, there's no reason for it to actually have to go through that entire centralized path. Why can't the message just go from me to him directly from our phone? So what we believe is that a new approach is drastically required to efficiently and affordably connect the world. And so what we've built with RightMesh is a platform that allows peer-to-peer connectivity directly between smartphones. So what that means is we use the wireless technology inherent in phones, so things like Bluetooth, Wi-Fi, and Wi-Fi Direct, to form direct links between smartphones. So in the case of sending a message to Alex, that can be done directly peer-to-peer. But if, let's say that everybody in this room is in an isolated island or a camp or something like that, if we all had some sort of application which was integrated with this mobile mesh networking technology, our phones would simply autonomously connect to each other and build a self-forming, self-healing network that allows us to be able to interact without the internet, SIM cards, or cell networks. So if I want to message someone on the other side of the room, what could happen is the data would go through the phones in between us rather than up through the internet. So from the refugee perspective, our goal really is to help bring connectivity to that huge number of people who are not connected today. But we're working on a number of different pilots and proof of concepts, and one of these, which we're in the product design phase of, is a mesh messaging application for refugee camps. So what that looks like is we want NGOs to be able to push out critical information to refugees within the camp who have smartphones, even if there's no connectivity available, or if it's unaffordable for people to access that. So they could therefore share information like services, education, employment, information about accessing visas, that sort of thing. It would also allow for peer-to-peer connectivity, so refugees can communicate amongst each other, volunteers, and the aid workers as well. And again, without a SIM card, internet, or cell networks. If people wanted to message somebody outside of that isolated camp, then that can be done so long as a few people have connectivity. They can then share their mobile data or sell it to other people within that network. So that's where the blockchain comes in, but I can speak to that a little bit later in the follow-up questions. So this is kind of at a very high level what that could look like. You could see 2 different camps on the bottom, which may have limited connectivity, or perhaps just one person has connectivity. Let's say that base station, for example. If there's some sort of headquarter in more of an urban core, they could therefore distribute information out from that point to the one internet connectivity point, and then it could be shared through the mesh from that point onward. So we're looking to pilot this next year. So if there's anybody who is interested or has an organization, please let me know. We'd love to work with other people who are interested in this kind of technology.
I'll just turn to, well, firstly to the algorithm half of the panel and ask, you all brought up fairness to a certain extent as obviously a core goal of anyone who's working in this area right now, something which is increasingly known to the public as a risk, I think, of any machine learning based approach. I am curious though, you know, if we're talking about outcome-led things, outcome-led prospects, how do we ensure, firstly, that employment really is what we want to optimize for? You know, a lot of people are miserable in work. A lot of people maybe might not want to just get a job immediately. That might not be the best outcome. And similarly, how do we avoid an approach which maybe matches the most successful people with the most successful places and gives everything to the haves and kind of rejects the people who it views as helpless and hopeless?
Yeah, I would like the second part is perhaps the most important. I think that was our main concern from the start. So from the beginning, we saw, well, algorithms tend to be stupid if you don't targeted and disciplined well enough. So that's really the role of those service constraints. And particularly, we saw very early in the process that if we didn't discipline the algorithm, not just with the language constraints, stuff like that, but also with distributional constraints. So making sure, for example, that the average case size is more or less similar across localities. Now what happened is, as you said, there are few localities very good at integrated refugees. The algorithm would send all the single people there without kids, so you don't waste space on kids that don't work anyway, and then you send single mother with kids to the divorce locality. So that's why it's really important to not just match like the numerical constraints, but also some distributional constraints. How to do that, and it complicates the work a lot, but thanks to our amazing operation researchers, we managed to do it quite decently. But it's also important, as Kirk mentioned, also to check ex post. And maybe you want the first part, completely agree again. Do you want to take that one, or?
Yeah, well, so on employment, that question, so there are two things. Number one is employment is where the data was, and so we got permission from the State Department to do that. But we know we don't want to stop there. And one of the most beautiful things about what we're doing around the United States is that there are communities, there are synagogues, there are churches, there are communities that are saying, we want to raise $50,000 and we have a house and we want to serve a family of 4. Another community is saying, it's an employer, and they're saying, I want to hire 5 machinists, I'm ready to train. Imagine the next steps of this tool. When we start to put that community data in there, we will be able to dramatically think of the preferences, account for the preferences of the refugee, and make sure that the long-term welcome by the community and the refugee are well matched, not just the refugee to the community. And when that happens, you will then see a change in the political discourse, because more people will experience refugees and the relationships that they can have with refugees directly, whereas right now it's just limited, and oftentimes it's just the same, and that's looking out for many years. So we started with employment, and Alessandro covered the points well about how we account for those challenges, and I'm trying to share what does the future look like to make sure that that future is beautiful and fantastic, and it's going to happen.
Yeah, so another way to rephrase your second question is how can we make sure, how can we inspect whether or not the refugees who are on the lower end of the distribution in terms of their baseline probabilities of finding work or some other outcome that we might care about, also improve in addition to those at the high end and the middle end. And in welfare economics, this is one of the sort of fundamental principles of fairness, not the only one, but it's one that that is measurable. And the technical term for what we want to see there is called first-order stochastic dominance of the new intervention over the status quo, and that's something that we did check in our back tests. I believe you guys also check that as well to make sure that the final product that we're testing is likely to lead to those sorts of outcomes, in addition to the subgroup bar plots that I showed. But at the end of the day, what's really needed here is perspective testing. It's one thing to see something in a backtest, and you definitely have to start with a backtest. It is tests on historical data, but we're doing something interesting here, and this is not unique to just trying to integrate AI into matching of refugees. This is something that is prevalent across the application of AI or machine learning to actual policy, which is actually using predictions, not just making the predictions. You can make predictions and you can see if those predictions are good, but then taking those predictions and then making decisions that intervene upon the data generating process in ways that are difficult to model, in some cases impossible to model. This is sort of one of the pieces that's the cutting edge of this sort of work. And the only way we'll really know is by continuously monitoring what the interventions are actually doing, and by running randomized control trials. So this is something I think we're all committed to.
Continuing the trend of me as a journalist asking very, very basic foundational questions to people who know far more about me. Snorre, Brianna, what's so hot about the blockchain and decentralization in this? Why not just chuck all of this through a nice big central server that's cheap for you to run, or put it in the cloud? That's cool.
Yeah, good question. So with respect to the centralization aspect, The issue with centralized ISPs and telcos are that they can be easily influenced and controlled by different governments and corporations to restrict access to content as needed. So things like censorship can come up, the abolishment of net neutrality, shutting down the internet completely, also being profit-driven. So maybe they won't be installing infrastructure in an area which is more remote because it won't be profitable. So that area will just simply never be connected. So there's some issues with the profit-driven mentality of centralized entities for connectivity. So in a decentralized model, what we can do is just use people's smartphone and the technologies that they already have to create network infrastructure. And so that is a way to very quickly affordably be able to bring that connectivity accessibility to people. So yeah, I think that's the part for that. And then for blockchain, we use blockchain for two particular reasons. The first is for being able to uniquely identify each node in the network. So because we're dealing with mesh networks where people may not necessarily be connected to the internet, we couldn't use IP addresses as the way to be the unique identifier. So we actually use an Ethereum address as that unique identifier, which is core to each phone which has a RightMesh enabled app installed on it. So that allows us to be able to identify each smartphone. We also use it for the incentivization aspect. So if you have mobile data that which you would like to share or sell to other users, that's enabled by, again, Ethereum and payment channels and allowing people to transact an ERC20 token for mobile data, even if they're several hops away from the internet.
I agree with a lot of stuff you say. And for our case, it's, as you mentioned earlier here, that you don't build on blockchain. You have to take architectural choice to see what does go on-chain, what does go off-chain, because there's a lot of computational stuff that doesn't need to go on-chain, and there's a lot of stuff that doesn't need to be represented as functions and data on-chain. Like, we are creating organizational structures, but we just need pointers to these organizations on-chain so they can be verifiable without our API. So that is kind of, we are building hybrid, we are using the cloud, we're using the databases, we're everything, because we got to build the support around the services to be able to provide the possibility to build out actual good data blob that is verifiable without our APIs. And we have to build out these registries on-chain so that these identifiers can be trusted. So that is where we kind of marched the battle for decentralization. But we also say that all these crazy dApps coming out, they're showcasing a lot of good stuff, but they're not viable in the long run. You got to have some. They need analytics to understand how the users use their platform to kind of go further, and you need to build more better off-chain architecture, but put whatever needs to be verified on-chain. So do you have a very intricate function, then make that on-chain so it's possible to verify.
How can you assure that you're not stereotyping the refugees that are applying?
Right, so you're thinking about which kind of observables we use in the training of the
It's really near the concept of stereotyping.
I mean, in that sense, I can see where you're going. So that is precisely why, if we didn't discipline the algorithm, you're completely right. Any kind of machine learning technology, any kind of prediction tool will tend to reinforce observation that we've seen in the past. So, if we let the machine learning algorithm completely unsupervised, completely without any check, then this exactly would happen. This is precisely the point. I cannot stress it hard enough. That is precisely the point of all the operational research part of the software. So in a way, the machine learning algorithm is the cherry on top of the cake, but that is really what constitutes the cake. In the sense that by satisfying constraints in terms of family size, the example I gave you before answers your question pretty well. If we didn't discipline this algorithm, we would be discriminating against single mothers with a lot of kids. The whole point of introducing these constraints, these serving constraints, these distributional constraints, is precisely to make sure that this doesn't happen. Similarly, then a second part, as Kirk correctly said, is about checking stochastic dominance. Are we making things better only for the top people or for everyone in the distribution? As it turns out, there's something that we have in common, both solutions have in common, we tend to make things best typically for the average person. So a little bit for the more disadvantaged people, a little bit for the best, mostly for the guys in the middle.
So my question is basically to RightMesh. So I have a background in network engineering and analytics for network engineering. I mean, what you're saying, I think, is technically possible if the content to be shared is within the small network. But most of the content is in the wider internet, like over-the-top provider like Facebook or Google or Amazon or like whatever these are. So you still need to access the internet at some point, and like you cannot go like with short range technologies beyond a certain point if the content that you need is really like still in the internet and still accessed through like the way the internet works now, which is big over-the-top providers being connected to big ISPs. So I'm not sure you can like go through go without the internet through this peer-to-peer model if you really want to access all the content that you need.
Yeah, absolutely. I completely agree with you. We still need the internet to be able to bridge those local mesh networks together. Right now, the way RightMesh is you can't just go and browse the internet through this network. However, that is something that we're building next year and the year afterwards, is allowing for general purpose internet browsing, but right now it has to be in the context of an application. But we're not saying that there's no place for the internet. We're definitely saying that they're complementary, and the mesh network can be used to help more efficiently spread information from the internet locally. So if you think about, like, we're all using the conference app right now to get like the conference schedule and different things like that. We're all having to take that down from the internet, but why can't just a couple people take it and then share it more efficiently peer-to-peer?
One of the big problems we've seen in Germany that a lot of people have built products for refugees, not with refugees. So it's a basic question to everyone: how did you engage newcomers in the development or in the design of the product?
It's a typical blockchain question about data security. How do you make sure that that data is secure, especially if it transmits from one mobile phone to another, from one device to another? How do you know that it's safe while it's doing that?
Yeah, hello, my name is Pierre from Terre des Hommes, a child protection NGO, and we contributed to negotiations on the Global Compact on Migration that is also dealing with the portability of skills and degrees in education. So I have a question for the SNOW, yeah, right, as to how can we possibly make the most out of what you propose, knowing that on the education side, governments remain quite keen to certify and ensure that their degrees and the education they provide is recognized by them through the system that you are proposing. Because if they buy in what you propose, I think one of the outcome of the Global Compact on Migration is already achieved.
As I mentioned, we work directly with the service providers. So in the United States, we're working with International Rescue Committee and the Lutheran Immigration and Refugee Service. They have service providing offices all across the United States, and at each of those offices, as well as from the headquarters, they're engaging directly with refugees. So I think that's one of the things that's really important to our lab, is that we're making sure that all of the research that we do is not only rigorous academically and scientifically, but also has the possibility for impact by working with service providers, and that's something that we have a lot of faith in them, that they are taking the concerns of refugees into account. I think that's demonstrated by their work. And
Mike, Alessandro, anything to add?
Yeah, our input on the first part of this tool is basically from those agencies, and it's from the staff that work on the tool. The reality is, and this is bad, but the State Department does not allow us or those agencies to actually ask refugees when they're approved to come to the United States, where they would like to go. And the State Department argues, well, they're not going to know the difference between Toledo, Ohio, and San Diego, California. But our long-term vision is to figure out how to get the State Department to allow us to do that. The way we did the tool is all of the data that we use, because it's a data tool, it's all de-identified data when it was passed on to the researchers. So,
as I said, we have focused on Uganda. That's also why we're traveling down there quite a lot every year. And we are really focused on user-centric design. We are focused on testing with the actual people who's going to use it and not kind of just take assumptions, because assumptions are the most scariest thing you can have, basically. So we need to verify our assumptions with the actual users. So that's why we go down and test it with the actual users.
And from our perspective, so for these initial requirements, we've been speaking with different international NGOs on that, and the next phase is to kind of select a site where we would go and do extensive research with the refugees for the exact requirements gathering before building out the full proof of concept. So yes.
So thank you to my panel, and thank you to you all for coming along.